Now we are going to solve the next problem related to bending stress. Here the problem is a cantilever beam of length L having circular tapering section of dia D at free end and capital 2D at fixed end. Find at what distance from free end maximum bending stress will occur. Also calculate the magnitude of maximum bending stress. Okay, so you have been given a cantilever beam which is tapered in section. So we know what is tapered section, whose diameter is varying throughout the length. So at the free end its diameter is given capital D, and at the fixed end it is given as 2D, and it is subjected to a point load at the free end P. Now at what end the bending stress will be maximum, we don't know at what end the bending stress will be maximum. That's why we have considered a section at a distance small x from free end. Okay, so at this section we can write the equation of bending moment, because we know by which formula we find the bending stress. The flexural formula, m upon I equals to sigma upon y equals to E upon R. This is the flexural formula that we use for finding the bending stress. So we can find m at this section, bending moment at this section, which is equals to moment of resistance. Also I is moment of inertia. If you have, this is the circular cross section, you have to find the moment of inertia. We know what is the moment of inertia for the circular section. Okay, now so what is this? What is moment of inertia for circular section? Pi d to the power 4 upon 64. Okay, now you can see the dia is varying throughout the length. It is capital D, and as we move towards the fixed end the diameter is changing. So at this section, suppose we have taken the diameter as dx. So first of all we will have to find the dx for finding the moment of inertia at this section. Okay, now first of all let's take that at a distance x from A. What is A? A is the free end. Bending stresses are maximum. That this thing we have considered. Okay, now the bending moment at this section will be mx will be p into x. Okay, p into x. So bending stress at top of xx. Now bending stress will be at the top and at the bottom also. The maximum may be at the top or as well as the at the bottom. So by the formula we know sigma equals to m upon I into y. This is equals to m upon z, because I upon y is the section modulus z. So sigma equals to m by z. So it will be p into x upon z is pi by 32 dx cube. Okay, that we know. For circular section z is I by y. I is pi d to the power 4 upon 64, and y will be dy 2. So z will be pi d cube by 32. Okay, now for circular section, bending stress at top of xx will be sigma equals to m by z. M is p into x, z is pi by 32 dx cube. So you have to find the diameter at this xx section. What is dx? As we have already found out this kind of problems in earlier questions, like deflection of tapered bar due to axial loading. There we have used this kind of concept. So dx equals to capital D plus 2d minus d upon L into x. So dx will be d upon L into L plus x. Now sigma will be px upon pi by 32 dy L plus x का whole cube equals to sigma will be 32 pl cube. The L cube will go upside. 32 pl cube upon pi d cube x upon L plus x का whole cube. So now for finding sigma to be maximum, what we can do, as we have already done in the previous problem, for any function to be maximum or minimum, what we do, we just differentiate with respect to the variable and we put it equals to 0. So variable is here x. So d sigma upon dx equals to 0. So it will be 0 equals to, we can differentiate it, 32 pl cube upon pi d cube, this is constant. And now a upon b, the differentiation of a upon b is b into differentiation of a means L plus x cube into differentiation of x is 1 minus x into differentiation of b, 3 into L plus x का whole square upon b square L plus x whole 6. So by solving this equation we can see x equals to L by 2, means at x equals to L by 2 the bending stress sigma will be maximum. Now what will be the value? we can just put the value of x into this function. We can find the value of sigma maximum. 32 pl cube upon pi d cube. X is L by 2 upon L plus L by 2 का whole cube. So from here you can see sigma max will be 128 pl upon 27 pi d cube, which occurs at top and bottom of mid length. Thank you.